Welcome to Unlock Layouts. In today's video, we are going to discuss the floor plan design. So in this schematic, right? So most of the devices are with some width value of 19.2 and length remains same because all the devices having the same length. So most of the devices they have divided by 19 by 2, and see this one is also this is a differential per unit. So these two differential per unit should have the same length and L and W value. So both have a 9.6 and 9.6. And apart from this, so we have other devices. So the devices and all we have 19.2. So upper we have one current mirror. So this current mirror it's a 19.2. So this current in this current mirror, so this is a kind of diode structure. So this M3 is a diode, and then bottom we have one more current mirror. So in this current mirror, so this M6 is the diode. So this is 19, this is 4.8, and then this is 9.6, which means, so if you divided this 9.6 divided by 4.8, so this will be a double size of this diode. So this is a normal diode, so this is the double size of the diode. And then now, so another we have one more complementary per unit here. So this is a PMOS and this is a NMOS, both CMOS structure they have tried to derive this. So this PMOS have a 76.8 micron and this NMOS is having 19.2 micron. See, again if you divided 76.8 divided by this 19.2, so most of time we will get 4 value. So which means the NMOS device is a smaller devices when compared to this PMOS. This PMOS is 4 times higher than this NMOS. So whenever we got some this kind of different types of values based on the schematics, right? So based on the standard value, here we have some standard value called 19.2. so even if you further, if you can divide, you can divide 19.2 divided by 2 also. Suppose if you want to make it as a smaller circuit, it will come for 9.6, some other value 9.6 will it come. So as far as we know, we are going with the standard value with this 19.2 only. Now I am going to do the layout. So just I am generating all the components to layout. See, everything is generated right now. So now we have this a 2 diff per unit. So this 2 is a differential per unit. See, just this 2 devices is the top devices. So we have that current mirror kind of structure. So this one is the diode and this one is the next device. So this 2 is a current mirror, and bottom we have 2 more devices. So this is the differential per unit. So these 2 has to be matched. We have a 2 devices here, 9.6 and 9.6. the value is, see here W is 9.6 and length is 60 micron. Sorry, length is 60 nanometer and W is a 9.6 micrometer. So now we have a 2 differential per unit. We have a above of that we have one current mirror unit, and then left and right we have a, see, such a huge device. So this device is a M5 devices, which means 4 times higher than the NMOS device. So this we can calculate 17.6. so this is 17.6, and bottom we have a 2 devices. It's just a current kind of, this is also kind of current structure. So now we have a one more devices, right, as we discussed. So this is a current mirror circuit, which means they mentioned it's I bias. So this is also a current mirror circuit. So now this is a schematic, and now we have a generated the layout. So in which way we can design the schematic for these devices? So before only we have calculated everything. So first what I am going to do, right? So I will go here. See, this is a huge device. So from my point of view, I am thinking it's a huge device. So what I am going to do, I am just going to click and make it as a property. So in this property it is showing it is 9.2. So what I am going to do, I am going to divide this 9.2 by 2 devices, which means it's come under 9.6. So further if you want, right, I can divide 4. So what I am going to do, I make it this as a 4 fingered device, this as a 4 fingered device. So the total length of 19.2. So just I am going to Q. So here we have a total number of width is 19.2. What I am going to do, I am going to make it as a 4.8, and then the number of finger, now what I am going to do, I make it as a 4. So apply. So however, the devices converted to 4 fingered devices, but the total width of the devices remain same here. So just apply and OK. See, the device size is it got shrinked from this texture to, so now I have shrinked to this texture. Same, I am going to apply the same parameter to this device also. What I am going to do, I am going to make it as a 4.8, and then I am going to make it as a 4 finger device. Apply, then OK. See, now this is the bottom, we have a current mirror, right? So this current mirror, we have a 4 finger device. I have converted this into 4 finger device. So further way, what I am going to do, right? So this, see now what I have done. So initially it was 19.2 because I felt this is a lengthy devices. So what I did, I just converted these devices into 4 finger devices. So in further way also I can extract these devices. So in which way I can extract? So see here I have a 4 finger devices, right? I can make it as a 2 finger, apply, OK. Then I can copy and keep the same devices. See now one device size is 9.6 micron with 2 finger, and I have a one more device, this is size also 9.6 plus 2 finger. So the total width is 9.6 here, here also the total width is 9.6. So 9.6 plus 9.6 into 2, so 9.6 into 2, it's the size wise it remains same. So now from the 4 fingered devices, it is integrated with 4 fingered devices. Now I have split it into 2 devices finger. So same I am going to do for here also. Now I have 4 finger device, I will make it as a 2 finger, apply, OK. Then I will copy and paste it the 2 devices here. See now, before it was a 19.2 micron lengthy devices. Now the same device, I didn't do any changes wise, parameter wise. The device parameters still remain same. See now we have a is equal to 2 and B is equal to 2. We have a 2 devices. If you want further, if you want to reduce, you can divide 9.6 divided by 2 also. So it's a 4.8. So just click and Q. So this is 4.8, right? So it's okay. So 4.8 is a lowest value only. So now this is a diode structure. These 2 devices, it's denoted, these 2 devices, it's denoted as a diode, and these 2 devices denote as a normal device. So usually whenever any layouts or any schematic designer will place the diode in between the matching, because since it is a current mirror, see current mirror we can go for a common centroid also, we can go for interdigitization also. It is not mandatory that current mirror compulsory we should do with interdigitization or differential pair, it should be done by the common centroid based on our requirements, based on our wish. Okay, so we have some kind of limitation, we have some kind of some kind of RC extraction they have to do, right? So some tolerance value will be there. So based on the designer, based on the schematic designer opinion, we can go for a common centroid also, and we can go for a interdigitization also. So now I am going to do the current mirror structure with interdigitization based pattern. So first what I am going to do, just I am going to move the source and source terminal, I am going to merge. So now A for align key, I am aligning with this here. See now in between device is the diode, right? In between device is the diode device, and then once we go for the schematic also, see source terminals are shared with the power net. So this is a schematic. So in the current mirror M3 and M4 both source terminals are shared with VDD. So just minimize it and go for it, then click and A. However, we are taking as a 2 finger devices. So since it is a 2 finger device, the middle net is a drain and both left and right corner is a source terminal. So now all the sources are connected together. Just merge the sources here. So this is one device, and one more device I am planning to place here, because I will keep the diode is in between left and right corner. I am making as a another one more devices, which means A A, which means suppose if you consider A as a diode, if you consider B as a diode, so B I am keeping in between. So these are two B devices. One second. So this is a one B and this is a one more B. So this two devices is the diode structure. So this 2 PMOS is a diode. So apart from this PCH and this PCH is the another devices. So based on this I am going to do the matching pattern. Now just I am going to align this one also here exactly. See, now I have matched. Okay, so even though before it was a lengthy devices, so now I have done some matching techniques here, which means, so this first device, if you are getting bit confused, see, right, if you are getting bit confused, so we can check out the schematic difference. See now this is a diode structure. Internal two devices are getting highlighted with white color. So this is a diode structure. Then we have opposite two devices. So this left and right corner I have placed. So I have placed the diode inside, and then left and right corner I have placed that one more device. So this current mirror matching is almost done, and still we have to add dummy. So as now I am not going to add any dummy over here. So just I am going to do this differential pair matching. So now the current mirror matching is almost done. So next what I am planning to do, so I have a two devices over here, that is a diff pair. So this diff pair I am going to do the matching here. So since we'll go to the parameter of the diff pair, just Q. So this is 9.6. So before also we have the same 9.6 with the single finger devices. So now what we can able to do, right? Same, we can convert this 4.8 into two finger devices. Okay, right? If you apply it, see the device width wise itself, it's quite common, because 9.6 I am not changing any parameter, just I am just converted the length divided by 2 and I make it as a finger as 2. So that's all I have done here. So no other major changes here. See, same for this is one more diff pair Q. See, this is also I am going to convert with 4.8 with two finger devices. Apply. OK. So now we have a two differential pair units with the two finger devices. So this is a one finger and this is a one finger. Since, and here if you noticed, right, source terminals are shorted here. See, if you take a short look of schematic, so this is a one more diff pair and this is a one more diff pair. This is a diff pair and this is a B diff pair. We have a two diff pairs here. So these two diff pair source are getting shorted here. So simply way I can make it as a this, all we know the two finger device. So left and right corner is always a source terminal. So now I have merged. See, now I have merged the two devices. See, I have merged the two sources of the devices. So this is one differential pair and this is one more differential pair. So parameter wise everything is same. So what I am going to do, click, I am going to make a move. I just moved that diff pair and I place it over here. So further way, if you want to reduce this 4.8, what can we do? 4.8 divided by 2, it's a 2.4. So shift F. So we'll do, so that things, okay, maybe we'll do later. Okay, maybe that things we'll do later. So now almost we have done the current mirror matching and as well as differential pair matching. So differential pair it's not matched yet, because see what happened, we have only two devices. So usually I am taking as a 4.8, that W is a 4.8, that I am going to take it as a common number. Okay, so that we can go for multiple number of layout also, no issue. So this is just a one kind of floor plan, we can go for multiple number of floor plan. So now go and click here. So this is also 4.8. So since already it's a 4.8, we don't want to change this, because already all the devices we are planning to take with 4.8. So and one more thing, this is as a 9.6, right? So we will convert this as a 4.8 and then we will make it as a finger 2. Then apply, then it's okay, right? So now we have a two devices over here. See, now we have a two devices with 4.8, 4.8. Okay, so almost all the devices size wise I am going to take as a 4.8. So now again we are coming to the figure. We have a two lengthy devices, which means, so as based on the schematic we saw something, right? So in schematic it is showing, see, these CMOS devices have 76 micron and then one more CMOS device is 19 micron. So what I am going to do first, I am going to divide this 76.8 divided by 19.2. So I am getting exactly 4 values. So what I am going to do, I am going to click, I am going to Q, I am going to the property of the device. This is not a 60 nanometer, so this is 776.8. so what I am going to do, I make it as a 19.2 as a standard length, and then I am making as a 4 finger devices. Just apply. So since it is not a 60 nanometer device only, okay, 60 nano, apply. See now, see these two devices have the same size. This is also 19.6 and this is also 19.6. So further way, what we plan to do, right? So we plan to do to make all the devices with 4.8, because I don't want to give any lengthy spaces. See, if you want, we can place these two devices over here also. It's not at all a issue. Since we have an area, it's not at all an issue for us. So just we can place these two devices here also, because here it's just a complementary mask, right? Here you don't need to do any matching stuffs, is not mandatory here. So still, if you want to look it into this 19.6, and then see, just we'll go to here. This is a 19.6. So before what we have done, right? Sorry, it's a 19.2, right? So 19.2 divided by 2, it's a 9.6. So I am going to take 9.6 micrometer with the 2 fingers. Apply. Okay. So now the device size is almost shrinked with the 2 finger. Then again it's a 4 finger device. Go to here. Since almost it's a 4 finger, again what I am going to do, I am going to make it as a 9.6. Same 9.6 micron. Since it is a 2, we need to make it as a double. So 4 into 2 is 8 finger device. So make it as a 8 finger device. Then apply. Still the parameters is same. 76.8 is a parameter. So still I am making the same parameter. Apply. Then okay. See now almost the device size from such a huge size, right? So now I have converted these two devices into two different kind of floor plan. See now we have this current mirror, and then we have the differential. Just I will keep it here, the current mirror circuit here. See now from the huge layout, right? So I have shrinked the size of, I have shrinked from 19.6, because each and all the devices have the different size wise. So size wise we have a different kinds of size, which means W. I am denoting as a W. So W is a different kinds of value. So now based on the schematic, right? See, this is a layout. See, this is a layout, and this is our schematic. See, but in our schematic, all the devices have different parameters, which mean apart from this differential pair, apart from this current mirror, so all the devices have different parameters. So lengthwise, gate lengthwise, all the devices are same, but the widthwise, W wise, if you consider, if you take a deep look, right, so all the devices have different W values, but we cannot do with the same W value. So we can do with the W value, but instead of going with such a huge W value, since we have some area constraints, suppose if you are bounded to boundary with some areas, so we can go for these kind of methodologies, so called converting the device into multiple number of fingers and multiple number of multipliers. So even if this area is not sufficient to us, suppose see, still we can further reduce the device size. Okay, just for an example here, this I made some kind of 4.8 based structure. So this is a one kind of structure. Okay, so now what can we do, right? So based on this we can add left and right one more dummies, and these are differential pair, right? So somehow if you add left and right one more dummy, so it will be equal to the current mirror size. So current mirror and diff pair will be the equal size, because suppose here it's a 4 devices, it's a 2 devices. So suppose if you add left and right 2 dummies, right? So this current mirror and diff pair will be a equal size. So this and this you can match, and since one more we have this current mirror, right? So we have some problem over here. The problem is, see now what I am going to do, right? Somehow these CMOS devices need not to be matched, because it's just a CMOS. So we don't need to match, because we need to keep it closer as possible, that's all. We don't want to do any matching stuffs here. So still we have some problem over here. See, suppose if you had two dummies, so just I'm copying, I'm pasting this device here, just I copy and paste it. Consider these two as a dummy, right? So consider these two as a dummy. So just I'm merging this dummy terminal to here. So this dummy with here, and then one more dummy we have this side, right? So this dummy with here. See, now I have added two dummies with the diff pair. So one sec, you can clearly understand this. So we have these NCH, right? See, this is the first differential pair. Which one is highlighting with white color? The first diff pair, and second diff pair is next to that. Left and right we have a two dummies, and then see, we have a current mirror parallelly underneath of the current mirror we have a diff pair, and then left and right we have a this kind of NCH, which means that complementary pair unit we have in the schematic, right? So here we have some complementary pair over here. So here we have some complementary pair. So this complementary pair I have added here, but still some part of the area, see, some part of the area is these two devices are still floating. So floating in the sense, top side we have still area. So here this area we can place some other devices, but now we don't have any other components to place. So further way also we can reduce this floor plan. Okay, so this is just a basic model how to convert the devices or how to make the devices if the devices are different kinds of widthwise the value, since the devices are having W values are same. So in this way we can approach. So this is a one kind of floor plan, and then we need to start the routing also. So routing part, okay, we'll take care later. So this is just a kind of how to do the floor planning. So this is not the way, it depends on person to person, right? So this is the way we can simplify the layout. So still further also we can simplify the layout. So this is just for example I'm telling. So still if you want, right, so we can make these two devices as a instead of making as a 4 multipliers, we can convert this as a 8 multipliers, sorry, 8 fingers. So this differential pair also we can convert as a 8 multiplier devices, and this we have a two different complementary pair units. So this and this both also we can make it as a, instead of 8 fingers we can convert as a 16 fingers or 32 fingers. So based on the size, so by making the parameter wise different kinds of W value, we can almost achieve our exact area, which something is called optimizing area, which means how efficiently you are utilizing the area. So in this way we can utilize the area. But see, whenever you got some schematic from the schematic design engineer, so they have to they will do some kind of simulations. So based on that simulation they have fixed some L and W value. So changing the finger or multiplier, it is not 100% advisable. So this is not 100% advisable, but if it is a worst case, you don't have any place or you don't have any area to route, or if it is any worst case, right, if it is a worst case, then you can change the device parameter, even the finger wise, even the width wise, or sorry, even the finger wise or multiplier wise you can change. But most of the time, see, device parameters you should not change, even the finger wise also, multiplier also. But if it is a worst case, we can change. So before we know, right, when we export these from the schematic, from the layout, so we have some uneven structures. Suppose if the designer don't want to do any changes with the fingers and multipliers of the design, you should not change anything. So based on the size only you have to start routing. So now we don't have such a kinds of what you say, we don't have such a kinds of restrictions here. So that's why I have converted the devices from 19.6 or 19.8 to 4.8, and I have converted the devices into 4 finger, 2 finger. So this is a kind of methodology we can optimize the area, so we can achieve our exact square shape and rectangular shape of the aspect ratio. So based on the chip wise, right?
I hope I have given some valuable information to you in this video. Thank you for watching my video. If you like this video, please click like button and share this video to your friends. For more details about this video, please contact us to my email ID and follow us on my Facebook page and Twitter page, and kindly subscribe our channel, and don't forget to click the bell button.